ba beep beep bom beep 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 bom beep ba ba bom ba beep beep bom ba beep beep bom beep ba ba bom ba 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 ba.
This grid is helpful in arranging ecological concepts, but it also may help when designing a research question. Let's see how some research might fit into this system. Let's take two researchers. Since we already have our organisms from the last act, let's look at two researchers who look at gypsy moth dynamics, Joe Elkington and Greg Dwyer. If you look at Elkington's research, he has done studies measuring gypsy moth populations over a season, measuring densities of different life stages during an outbreak, as well as looking at effects over a few years and maternal effects, seeing if the quantity of food females consume affects their offspring's viability. And finally, in an impressive 14-year study, Elkington collected data on gypsy moth mortality, deer mice, and acorn production. The data imply that population dynamics of gypsy moths were most affected at low densities by deer mice, and the number of deer mice was determined by the number of acorns, which are one of the mice's main food sources. So in years of low acorns, the mice population declines the following year, and there are fewer mice to eat gypsy moth pupae. So a bad year in acorns may actually allow gypsy moths to reach outbreak populations. Dwyer has used mathematical models to examine gypsy moth dynamics, and much of his research has fleshed out details of scale. Some of Dwyer's work includes looking at how populations of gypsy moth emerge synchronously over large distances. He's also looked into community levels with modeling the interaction between gypsy moths, their predators, and pathogens. He shows that outbreak populations in the moth can be explained by incorporating a random component in traditional predator-prey and host pathogen models. He has also looked at landscape ecology levels by looking at spatial scale and the effect it has on transmission of fungal disease of gypsy moths. The combination of these boxes helps to give the specifics of the story. So for Dwyer's model on the effect of spatial scale, it was important for him to know Elkington's work on the relationship between number of eggs laid and how many of those reach reproductive age. And Dwyer's model, looking at why gypsy moths might disperse, may be used by Elkington to explain patterns that he measures. So if you were interested in researching another aspect of the system, you might choose to study the community at a shorter time interval. You might be interested in the relationship between predator and diseased prey. Do mouse predators avoid gypsy moths infected by the virus? You would then draw heavily on the work that has previously been done, and similarly, if you were interested in the dynamics of zebras, lions, and zebra pathogens, you might draw on the models by Dwyer. However, the population dynamics might be different, or the individual differences between insect and mammal might create a different scenario, and in the process, create a different puzzle.